Hello, my Precalculus students. Welcome back to video lesson number 3 for section 5.1 on trig identities. So hopefully you've watched the first 2 videos and you start to have maybe a good grasp of the trig identities we are using, and you tried the first homework assignment. Now we're going to look at some different type of problems. We are going to use the identities and your algebraic knowledge to simplify trig expressions. Okay, so these will not be numeric answers. You're starting with a trig expression that involves multiple different trig functions or multiple terms and multiple factors, and simplifying it down to just a single trig expression, or maybe a product of 2 different trig expressions, something like that. But basically, you're taking something that looks complicated and making it look easier using a couple different things. We're going to use the trig identities we talked about, but also you're going to be using algebraic tools that you already know, things like factoring, things like multiplying out, like FOIL, for example, multiplying 2 binomials. If you're adding or subtracting fractions, getting a common denominator, um, rewriting division as multiplying by reciprocal, all a bunch of different algebraic tools that you already know. You've used these before in other types of problems. Now we're going to apply them here. So as I said last video, the first video, these problems often are challenging because you might not know right away what method to use. So my best advice I can give you is to just try different methods. Try something. If it doesn't work, go back and try something else. Look at other example problems. Look at the identities, should kind of give you a hint what to use. Think about algebraically other things you've done in the past. And with these kind of problems, hopefully the more you do them and the more problems you see, you start to know by looking at the problem what kind of methods you will use. But a lot of times it'll be trial and error. You try something, it doesn't work, you go back and try something else. Okay, so these will take a while and a lot of practice, and I will be here to help you the best I can. So let's do some of these examples together. First one here, simplify secant negative theta times cosine pi over 2 minus theta. Okay, uh, well, as I mentioned before, whenever we see a negative theta, that tells us to use our odd or even identities, all right? And whenever you see pi over 2 minus theta, that tells us to use the cofunction identities. So let's start with the odd or even. Secant, if you remember, is even, since secant's reciprocal of cosine, and cosine is also even. Secant's even. So that means that secant of negative theta is the same as the secant of theta. All right. And then next one, uh, cosine of pi over 2 minus theta. Cosine pi over 2 minus theta uh, is the same as the sine of theta, right, from our cofunction identities. All right. So that looks a little better. I have secant theta times sine theta. Okay, well, I can simplify it even more. All right. Um, if you remember, I said before that we can always write tangent, cotangent, secant, cosecant in terms of sine and cosine. So if you're not sure what to do, that's always a good thing to try. Write everything in terms of sine or cosine and see what happens. Well, secant is 1 over cosine times sine. And now I can make that one fraction. I can make that sine theta over cosine theta. And what do you know? Sine over cosine is tangent. So that expression just becomes tangent theta. That's what I mean by simplifying. I take an expression that looks challenging, make it look easier. So this expression right here is equivalent to tangent of theta. All right, next one. Simplify this. Sine cubed x plus sine x times cosine squared x. Now, let's see. Well, our first thing, if look for any identities. You don't see any identities right away. We see a squared there, but it's not like sine squared plus cosine squared or anything, so I don't see a Pythagorean identity. All right. Well, what else do we know? What else could we try? We said before, write things in terms of sine or cosine. It already is in terms of sine or cosine. Okay, that won't help. Well, is there anything algebraic I can do? Algebraic, since I don't see any identities I can use. Well, yes, I can do something algebraic. Look what we have here. We have 2 terms. This has sine cubed x. This has sine x times cosine squared x. Both terms have a sine x, don't they? Both terms have a sine x. Since both terms have a sine x, I can factor it out. I can factor out that sine x. Sine cubed x, if I take out one sine, I'm left with 2 more sines, so that'd be sine squared x, and take a sine x out of this term, and I'm left with cosine squared x. So I have sine x times the quantity sine squared x plus cosine squared x. And now, hey, what do I know? That should look familiar. That's one of our Pythagorean identities. Sine squared x plus cosine squared x is just 1. And if you don't know that yet, you will learn it very soon. We're going to see that a lot. And so what are we left with? We're left with sine x times 1, which is just sine of x. So there we go. This whole expression is equivalent to just sine of x. All right, those two are pretty simple. All right. Let's go to the next one. All right. These last couple will be a little more steps. It will take a little while to get there. All right. So let's start with this. What do we see here? We see two things in the numerator multiplied together, right? We see secant x plus 1 times secant x minus 1 multiplied together. All right. Well, let's FOIL that out and see what happens. So I'm going to get secant x times secant x is secant squared x. And then my middle two terms, I'll have a secant x and a minus secant x. Those will cancel out, right? One's plus, one's minus. So I'm just left with minus 1 over sine squared x. So I fold out the numerator, and the two middle terms cancel, so I'm left with secant squared x minus 1 over sine squared x. All right, well, what can I do next? Well, let's see. I have a squared, so this looks kind of like a Pythagorean identity. So flip back to the front. What Pythagorean identity involves secants? Well, let me write this to the side here. We're given that 1 plus tangent squared x equals secant squared x, right? That's one of your Pythagorean identities. Well, sometimes those Pythagorean identities I use, but in a different form. Can I do anything algebraically to make this look like the numerator? Yes, I can. I can move the 1 to the other side. So I can subtract 1 and say that tangent squared x is secant squared x minus 1. All right, so we're going to use that sometimes with those Pythagorean identities. We will rewrite them algebraically to make them look a little different, but still using the same identity. All right, come back to this. I can replace secant squared minus 1 with tangent squared. So I have tangent squared x over sine squared x. Okay, a little bit better. I got rid of the minus 1, but I still have two different trig functions here, tangent squared over sine squared. What can I do? Well, let's see, I mentioned before, I can write tangent as sine over cosine. Tangent is sine squared over cosine squared, and that is all divided by sine squared x. Okay, well, that looks more confusing though. I've got a fraction in the numerator of a fraction. Well, remember, we can always rewrite division as multiplying by the reciprocal, so let's do that. Let's start with our numerator, sine squared x divided by cosine squared x. Instead of dividing by sine squared x, let's multiply by the reciprocal. Let's multiply by 1 over sine squared x. Okay, and hey, what do you notice? Now I have a sine squared x over sine squared x. Those two cancel out. I'm left with 1 over cosine squared x. And one more step. Reciprocal of cosine is secant. So 1 over cosine squared x is the same as secant squared x. There we go. So this whole expression right here is the same as secant squared x. Okay. Oh, side note, you know a nice way to check that on your graphing calculator? This is an easy thing to do. Graph this expression under y1 and graph this under y2. You should see one graph, because if they're the same expression, then the two graphs will overlap. So that's always a good way to check. Graph both these expressions, and if you see the two graphs overlap, that means they're equivalent. All right, so that was example 5. Let's flip now, to example 6. There's one more to do. Simplifying trig expressions by combining fractions. Okay, this is one method we're going to use very frequently. Anytime we're adding, subtracting, where we have fractions, you know what to do algebraically. We need to get a common denominator. Okay, so let's do this here. Cosine over 1 minus sine minus tangent. Okay, I don't see any identities. Okay, now you might say, oh, well, 1 minus sine squared is cosine squared. That is correct. But this 1 minus sine, we can't use that. There's no squared involved. To use the Pythagorean identities, it has to be a squared. Okay, so I don't see any identities I can use. But what I can do, I know, is I can write tangent using sine and cosine. So I'm going to rewrite tangent. The first part will stay the same. Cosine theta over 1 minus sine theta minus, I'm going to rewrite tangent theta as sine theta over cosine theta. Okay, now I'm subtracting two fractions. Well, as I mentioned before, anytime I'm adding or subtracting fractions, I want to get a common denominator. And the LCD, the least common denominator, is just going to be the product of the two denominators. Cosine theta times 1 minus sine theta. That's my LCD. So I want to get both fractions that have a denominator of cosine theta times 1 minus sine theta. All right, so let me do that now. Let's rewrite that. So this is cosine theta times 1 minus sine theta minus sine theta over cosine theta. Okay, so let's get my common denominator. So I want to have cosine theta times 1 minus sine theta in the denominator. This fraction has 1 minus sine theta. So let me multiply it by cosine theta over cosine theta. This fraction has cosine theta. So let me multiply it by 1 minus sine theta over 1 minus sine theta. Right? This is a skill we use all the time in math. We get a common denominator by multiplying a fraction by the same thing on the top and the bottom. Okay, so what do I have now? I have my common denominator is cosine theta times 1 minus sine theta. All right, and do not multiply that out. Leave that in factored form. You'll see why in a little bit. So what am I left with in the numerator? Well, cosine times cosine is cosine squared theta. Okay, and then here I have minus sine times 1 minus sine. Now, you might want to write these in parentheses because you have to distribute the sign to both terms. And let me just make this plus and negative. Let me distribute the negative sign. So negative sine times 1 is minus sine theta. Minus sine times minus sine is plus sine squared theta. Okay, so I have cosine squared theta minus sine theta plus sine squared theta all over cosine theta times 1 minus sine theta. All right, now be careful. Do not try to cancel anything out. Sometimes students say, oh, cosine squared over cosine. Those can cancel. No, those cannot, because you can only cancel by division if everything's in factored form. These are factored, but there's no factors on the numerator. In the numerator, these are adding and subtracting. You need factors before you can cancel. Okay, but notice, do you see any identities? Hopefully you do. In the numerator, look what we have. We have a cosine squared plus a sine squared. Hey, that's equal to 1. So let me replace that. Cosine squared plus sine squared. Of course, it doesn't matter that they're not next to each other. It's plus, so I can just move it around if I want to. Cosine squared plus sine squared is just 1. So I'm left with 1 minus sine theta over cosine theta times 1 minus sine theta. Okay, now what do we notice? Now I have a 1 minus sine theta in the numerator. Hey, that matches the 1 minus sine theta in the denominator, okay? Because this is all factors in factored form now, and the numerator is just one factor. 1 minus sine theta is not added or subtracted anything else. It's a factor by itself. This factor and this factor can cancel by division. So what am I left with? 1 over cosine theta. What's that equal to? Reciprocal of cosine is secant. So secant theta. There we go. So one more time, this whole expression right here is equivalent to secant of theta. So that's what we're doing in this section here. We're simplifying identities by taking an expression that looks complicated, making it look easier. All right, so as I said before, there's many different methods that you can use. So you're not going to look at the problem and know what to do right away. You have to try different things. All right, look for different trig identities. Look for a cofunction. Look for odd or even. Look for a Pythagorean. If you don't see anything right in terms of sine or cosine, look for algebraic things to do, like factoring, like multiplying out, like getting a common denominator. Different strategies you want to try. Okay. Uh, so there's quite a few homework problems I want to give you over this, practicing simplifying expressions. Same also on page 403, 9 through 16, 27 through 30, and then 34, 36, 38. My suggestion is to do these in parts because this first section here is a little bit easier. These get more challenging. So I would try 9 through 16 first. Those are easier. Those usually take 1 or 2 steps, maybe 3 steps at the most. Those would be easier ones to do. So try 9 through 16 first, and you can check with me if you want on those before you go on to try 27 to 30, and then the last 3, 34, 36, 38, these are all like example 6. All these involve getting a common denominator first, okay? So try those out, and as I said, if you want to check the first section with me before you move on, you can do that, and then let me know if you have any questions, okay? Good luck to you.